Welcome back to West Virginia, where life is a circus. Okay, so ready for joke of the day? Because it is the best part of the day. Well, what do you get if you cross a Christmas tree with an apple? A pineapple. All right, well, enough pining on with joke of the day. Let's pine our way into radical equations. So radical equations have a radical in them, a square root, but the catch is your variable is underneath the radical, like you can see right here. Notice that my x here, and if I can stretch my radical out just a little bit better, there we go. My x is buried underneath that radical. Now notice whenever I want to solve my equations, I want my x freed up. I don't want it buried underneath that radical. So what I'm going to do is I'm going to take a look at this and I'm going to say I need to get the radical out of the way. Well, what would it take to get that radical out of the way? In other words, what would undo a square root? The opposite, just like the opposite of multiplication is division, the opposite of addition is subtraction. What's the opposite of square rooting? Absolutely, squaring. So what I'm going to do is I'm going to square the side, and what you need to understand is that when you do something, you do it to the side, not to individual terms. Whenever you multiply the side. Whenever you add or subtract to the side, not to individual terms. So I'm going to square this side, and I'm going to square this side, because squaring and square rooting cancel each other out, and you are left with what's underneath that 20 minus 8x. And the beauty is that the x is freed up, and I do not have a square root there anymore. So I'm now able to solve that equation. Now notice it is a quadratic at this point. It's a second power. And when I have a quadratic, I got 4 ways to solve it. I can either factor it, I can take the square root of both sides. Well, I don't want to do that because that will take me back where I was. I can complete the square, which is a great option, but if factoring doesn't work, at this point most people will head for the quadratic formula. But regardless, because it is a quadratic, I definitely need to set it equal to 0 and then go from there. So I can either slide my x squared over to the other side, or I can take my 20 minus 8x and slide it to this side. Most people like to have their highest power positive, so I'm going to slide both of these to this side. What that means is I'm going to add that 8x, and I'm going to subtract that 20. Because remember, the sign in front is the sign that goes, so the opposite of positive 20 is minus 20. The opposite of negative 8x is to add an 8x. Now I've got my quadratic, I'm ready to solve it. And I'm going to attempt to factor, because if it will factor, that is the easiest way to do it. Now there's nothing common that I can divide out of every single term, and you know that's what you should do first. So I'm ready to head for that double parentheses, and I know that this back sign being a minus tells me that I'm going to have opposite signs. One's a plus, one's a minus. Now I'm going to split this into the front 2 slots as an x and an x. I'm going to split this into the back 2 slots. So now I'm looking for 2 numbers that will multiply for 20. They're going to subtract for an 8 because these signs are opposites. That would be a 10 and a 2. 10 times 2 is definitely 20. 10 minus 2 will give me an 8. So just check outsides and insides to make sure the signs are correct. I have a negative 2x out here and a positive 10x in here. That gives me a positive 8x, which is exactly what I wanted. So I know that this is factored correctly. So now I'm going to employ that zero product principle that says if I've got 2 things multiplied together to get a 0, one of these 2 has got to be the 0. So either this x plus 10 is the 0, and if that's the case, x is going to be a negative 10 because I'll just subtract 10 from both sides, or the x minus 2 is the 0, in which case x is 2 because I'm going to add 2 to both sides. But now I have to be very careful because recall there was a radical there from the beginning. So these are the 2 numbers that I should be able to plug in right here and get the left and the right side to be the same. However, because of the radical, strange things could possibly happen. So I do need to check to make sure that these actually do work to see if there's any extraneous solutions. So I'm going to check my x minus 10, or my x equals negative 10, and I'm going to put that negative 10 here and here. So when I put the negative 10 in here, I will have square root of 20 minus 8 times negative 10. And I had better get a negative 10 when I get that result. So now underneath the radical, negative 8 times negative 10 is going to be a positive 80. And so I have 20 plus 80, which is 100. Now here's where it gets interesting. Because remember, technically there are two numbers that I should be able to multiply together to get 100. A positive 10 as well as a negative 10. However, this indicates principal square root. When the square root is already on the page and you're not taking the square root, it's already on the page, then that means you're only focused on the positive square root. So that means this is going to be a positive 10. I'm completely ignoring the negative 10 that could come out of that. So this says 10 equals negative 10, which is definitely not true. So this x equals negative 10 is what we call an extraneous solution, also called an extraneous root. In other words, it should work because my math was done correctly, but when I plug it back in, it causes problems. Now let's check our x equals 2. Let's plug that in and see if it works. So I'll just go ahead and erase all this because we've already taken a look at that. So I'm going to put my x equals 2 in there. And so when I plug my 2 in, I get 20 minus 8 times 2. And I put my 2 on this side. Now 8 times 2 is 16. So I have 20 minus 16. And 20 minus 16 is 4. So I want the square root of 4. Once again, principal square root of 4. Technically, there's two numbers I should be able to multiply to get a 4. A positive 2 as well as a negative 2. Because negative 2 times negative 2 is positive 4. But this indicates I'm only focusing on the positive one. So that results in a 2 equals 2, which is correct. So this is not an extraneous solution. It is a solution. So hopefully what you're seeing here in terms of the steps for solving your radical equations is you definitely need to square both sides. And once you square both sides, you will have a quadratic that you will be able to solve. So solve the resulting quadratic using any of those 4 quadratic methods. But then you need to be sure to check those solutions for those extraneous roots. Check the solutions for extraneous roots. Very important step. Now, notice that I actually skipped the first step because the first step comes in line with the next example. Recall me saying that whenever I square something, I square the side. I cannot square individual terms. So as I'm looking at this, I'm saying that square root's causing me problems. I can't go like this. I can't just square the term. I have to square the entire side. Now, watch what happens if I go ahead and square the side as it is. I square like this, and don't write this down because this is definitely not correct. But what would happen is I would have a square root of 2x plus 15 minus 6 times another square root of 2x plus 15 minus 6. Whoops, that's going to be inside the parentheses. And now I'm going to FOIL this. Now when I FOIL it, when I take a square root of 2x plus 15 times another square root of 2x plus 15, it's going to be fine because the square roots will cancel out and I'll get a 2x plus 15. Not a problem here at all. Here's where the problem happens. When I do outside here, I get a negative 6 times the square root of 2x plus 15. On the inside, I get another one of those, negative 6 times square root of 2x plus 15. Now in the back, it'll be great. Negative 6 times negative 6 is positive 36. But here's where my problem is. When I combine those, I get a negative 12 times the square root of 2x plus 15. And my point is this. I have retained the radical. I have not gotten rid of it. And ultimately, what I really want to do is I want to get rid of that radical. So, recall, I have to square the side. So maybe what I need to do is I need to get it so that that square root is completely by itself, like it was in the previous example. See, the radical here was completely by itself. So when the radical is isolated and it's totally by itself, I can square the side and it'll get rid of it. So that is actually, that very first term is to say, let's isolate the radical. Let's get it by itself so that when we square both sides, the radical will disappear. So if that's the case, and we flip back over to that second example one more time, instead what I'll do is I will get rid of that -6 and I will slide it to the other side. So I'm going to add 6 to both sides, and when I do that, we'll isolate this radical, and on this side I'll have an x plus 6. Now I'm ready to square both sides, because at this point when I square this side, squaring and square rooting cancel each other out, I'm left with 2x plus 15. And now I'm going to, remember, I'm squaring the side. I'm not just squaring this term, I'm not just squaring this term, I'm squaring this side. And recall what that indicates is I'm going to take my x plus 6 and I'm going to multiply it by another x plus 6. I'm not just going to distribute the power, even though it's so much fun to sing that song. But that's not what's going to happen here. I'm actually going to FOIL this out. So when I do, I get x squared plus 6x plus another 6x plus a 36, and now I have a quadratic. So I'm ready to solve the resulting quadratic with any of those 4 methods, but that means I definitely need to set it equal to 0. So I'm going to slide all this over to here so that I can keep my highest power positive. I'm going to combine a 6x and a 6x to get a 12x. Hold on a second here. Let's do this so that we don't confuse ourselves. Now I'm going to slide my 2x over. So 12x minus that 2x will be 10x. 36 minus that 15 will be 21. And now I'm ready to solve that quadratic. And yet again, if it will factor, that's the easiest way to go. So I'm going to give factoring a shot and see what happens. There's nothing common that I can divide out of every single term, so I'm headed for the double parentheses. This tells me signs are the same. This tells me both pluses. I'm going to split my x squared into the front slots. Now I want 2 numbers that will multiply for 21 and add for 10. That's a 7 and a 3. So now what I have is that either this is the 0 or this is the 0. So either the x plus 7 is the 0 or the x plus 3 is the 0. Now if the x plus 7 is 0, x is a -7. If x plus 3 is the 0, x is a -3. But recall, I need to check for those extraneous solutions because it could be that when I plug it back in the beginning, it causes problems. So when I check my x equals -7 and I plug -7 in here and here, what's going to happen is I'm going to get 2 times -7 plus 15 under the radical, and then I'm going to subtract a 6. And I better come up with a -7 when I'm done with that. Let me slide that a little bit further to the left so we have room to check this one over here. So once again, I've got a 2 times the -7 plus 15. I'm going to subtract a 6. I better get a -7. Under the radical, 2 times -7 is -14. -14 plus 15 is a 1. And recall this idea of principal square root. Technically there's 2 numbers I can multiply together to get that 1, but I'm only concerned about the positive square root. So I have a 1 minus 6 is -7, and 1 minus 6 is a -5, and -5 definitely is not a -7. So this is what we call an extraneous root, an extraneous solution. Technically it should work because I did all my math right, but when I plug it back in it causes problems. So now let's check this one. So when I take that -3 and pop it in here and here, I will get 2 times -3 plus 15, and then I'm going to subtract a 6, and I better get a -3 when I do that. So under the radical, 2 times -3 is -6, and I have -6 plus 15 under that radical. Then I'm going to subtract a 6. I better get a -3. -6 plus 15 is 9. And once again, the idea of principal square root. Square root of 9 is 3. Technically, it would be positive and negative 3, but I'm only worried about the positive because this is principal square root. I didn't take the square root. It's already on the page. And 3 minus 6 is a negative 3. So sure enough, I did get the same thing on both the left and the right sides. This is my solution. Now, you may be noticing that in this case, the first answer was extraneous, the second answer was not extraneous. That was also the case here, that the first answer was extraneous, the second answer was not extraneous. That is just a coincidence. It doesn't always happen that way. In fact, it doesn't always happen that one is extraneous and the other one is not. Sometimes they're both extraneous, in which case you have no solution. Sometimes neither is extraneous, and they're both solutions. But the idea is you definitely need to check for those extraneous roots to see, is there something that's going to cause problems? So, once again, let's try one more example just to make sure that we're very good at this. Enjoy the scenery and the show behind me. Quite a circus going on here in West Virginia as well, across the whole world. It can be a circus, can't it? Crazy, crazy times. Okay. So, one more example, and I believe we are on, yes, example C. And this one says we've got x minus square root of x plus 11 equal to 1. So once again, the idea is this radical is causing me problems. I want to get rid of it. I want to square it. But I can only square the side. And as we saw before, because I kind of have a loosely set a binomial there, when I square it, I'm going to retain that radical. So I need to isolate the radical and get it by itself. So what I'm going to do, notice that I could slide the x over, but that'll be negative. Or I could slide the radical over and bring the 1 to this side. Either way, it's going to be perfectly fine. Now, if I subtract that x, recall, sign in front's the sign that goes. You put your name tag on the front when you enter a meeting. You never put your name tag on the back because I won't know who you are. So sign in front's the sign that goes. This is a negative in that radical. Now, when I subtract that x to the other side, I have negative x plus 1. Most people like that to be positive, so you can divide through by that negative, and basically what happens is you change the sign of every single term. And now I am ready to square both sides. So I'm going to square this side. Remember, you're squaring the entire side. And I'm going to square this side. Square the entire side. So squaring and square rooting cancel each other out. I'm left with an x plus 11. And on this side, I have an x minus 1 times another x minus 1. And I'm ready to FOIL that. So x times x is x squared. On the outside, I get a minus x. On the inside, a minus x. And in the back, I get a positive 1. So I'm going to combine up those like terms on the right-hand side. Negative x minus x is a negative 2x. And now I'm going to slide all this over here because I have a quadratic. And in order to solve a quadratic, I'm going to set it equal to 0. Hopefully factor. If not, I can do the completing the square, or I can do the quadratic formula, whichever one you want. So I'm going to take my negative 2x and subtract an x, which gives me negative 3x. I'm going to take my 1 and subtract an 11, which gives me a negative 10. And now I am ready to go. I'm going to attempt to factor this. So there's nothing common that I can divide out. This tells me different signs. One's a plus, one's a minus. Split my x squared up into the front slots. And I want two numbers that are going to multiply for 10 and they're going to subtract for a 3 because the signs are different. That's a 5 and a 2. So I'll put the 5 here and the 2 here. Check those out insides and outsides to make sure I've got it right. Out here I get a negative 2x and here a positive 5x. And a negative 2x plus that 5x will give me a positive 3x. I wanted a negative 3x. But remember, when I have right number, wrong sign, very easy to fix. Just switch those signs. This becomes the negative, this becomes the positive, because now I have a positive 2x, a negative 5x, which gives me the negative 3x that I wanted. Here is that zero product principle that says when two things are multiplied together to get a 0, one of them has got to be the 0. So either the x minus 5 is the 0, in which case x is 5, or the x plus 2 is the 0, in which case x is a negative 2. But remember, I need to check both of these to see if either one of them is an extraneous solution. So when I check my x equals 5, And I'm going to put that right up here because I guarantee I'm going to run out of room on that. Checking x equals 5. I'm going to put a 5 here and a 5 here. So that's 5 minus square root of 5 plus 11. I better come up with a 1. Now 5 plus 11 is going to be 16, and once again, principal square root. I'm not worried about the fact that I could get a negative 4 out of that. I'm only focused on the positive. So 5 minus 4 is 1. Sure enough, 1 is 1. That is the correct answer. Now let's check our x equals negative 2. It could be extraneous, or maybe both of them work. So when I put the negative 2 in here, I get a negative 2 minus square root of negative 2 plus 11, and I better come up with a 1. Now, negative 2 plus 11 is 9. And once again, that idea, the principal square root of 9 is 3. Not worried about the negative 3. And negative 2 minus 3 is a negative 5. That does not work. So this is an extraneous root. Should work. Mathematically, technically it should work. But it doesn't because it causes problems when I plug it back in. So this is how you solve radical equations. Now notice that in all these examples, I only have one radical in the equation. It is possible to have two radicals in there, and then there's certain steps that you'll take with that. But this video is simply limited to having one radical in your radical equation. And I hope it helps. Have a fantastic day.